Hello viewers, it is Abjoin Babatunde Gupola again for this channel, Nobel Episode Designer. You are welcome back. To the new viewers, Nobel Episode Designer is a channel for episode design service. We release videos, free videos on our website www.nobera.com and on our YouTube channel that you're watching currently. On process design and on process simulation and engineering drafting, on PNID, PFD, optimization, and everything that's related to process design section in chemical engineering, and even some chemical engineering theory. So we are planning on doing videos on those two. You understand? So so we have released some videos on Aspen Plus, Aspen HYSYS, and today what we are doing is to further our course on Aspen HYSYS. So we are going to be working on petroleum characterization, the basis of petroleum characterization in Aspen HYSYS. So that's what we are doing today. So stay tuned and always share our content with your friends so you can get more people, and to also encourage us to do more. We are just starting, so but we need your support and for you to share. You need your support to share our platform among your friends. So if you see a lot of people actually giving us feedback, we to be encouraged to do more. Yes, I think, and it will also increase. So what to do for petroleum characterization, like my video on petroleum characterization in Aspen Plus, is basically the same thing. So but we want to model petroleum system because petroleum used to contain a lot of compound, so that cannot be modeled. A lot of compound composition or components that cannot be modeled explicitly as an HYSYS component. So we have to model it as a hypothetical components in Aspen HYSYS. So but we can still add. Well, the first thing we are going to do today to start the process, because I want to take it one step after the other, is we are going to add some component that we call light end. I have not deal with light end before. Light end are just light or low boiling point components, just like propane, carbon 1 to carbon 6. You understand that that can special analysis can be done on petroleum to determine composition. So instead of actually modeling those components with all these big alkanes, you know, all these residue components that they are not specific and difficult to model, you can model them explicitly, you understand, which will actually increase the accuracy of your simulation. So I'm going to be adding those components now. And also CO2, so you can just model it as a part of your model. It will increase. So instead of actually using hypothetical components for those components, so they used to do special analysis for those light end components in the petroleum testing laboratory. You understand? And they'll give you the composition and you can add it to your simulation or your modeling. You understand? So I'm going to be adding the modeling. This way we add component list in Aspen HYSYS. So you add the component that you're going to use in the simulation here. So I'm going to be adding them. So you can this is choosing as ISIS component. You can choose Aspen properties, which is like Aspen plus components and stuff. So I'm going to be choosing Aspen ISIS component list. So you just type the name of the component, and so I'm going to start with carbon 1, which is methane. Then carbon 2 is ethane. So I'm just going to be adding it. So well, I don't want to spend a lot of time doing this, so I'm going to skip this video to the end. Okay, so this is the end of adding the component. So you, like I said, you just type in the name of the component, then you press this add it to add the component to the component list that you're using from the data bank that you have. So all this one contain the property of the components, pure components you some from the thermodynamic institute here. So you can check key components from here. So you see the data bank that they are inside the critical properties. Here's another one point, the temperature, critical temperature, the volume, you understand, the critical volume and pressure. So you see the warning point, see all the other property, period dependent property of the gas phase, vapor pressure, you understand the parameters for the vapor pressure. So another other property that you want to add, yes. So you can edit the properties if you want. Well, that's what it is. So the next thing when you are done with the component is to determine the flow package in order to calculate the stream properties, the mixing value, you understand, the binary interaction of the component. So I'm going to be using Peg Robinson model because that's the best for petroleum system. Then the next thing you go to is the oil manager. Yeah, over here. So once you click the oil manager, you are going to have this environment. So you start to add this petroleum asset when you want to do more rigorous asset management, like you say, or improve asset management. But we are just doing the basic one now. You understand? So once you get it, next thing you do is to input the assay. What do we call assay? Is like what I said, experimental codes, just a part of the like sample of your crude oil you understand that you test in the laboratory. So you have to give the testing results of the lab from the laboratory to Aspen HYSYS in order to classify as a crude oil. So you can add the assays now. So I'm going to say assay 1. You don't need to be changing the names. You can change the name that you want over here. Change the name if you want to. I'm going to be adding the properties. So to write the properties of assay, there is a lot of form to fill. The first thing is the block properties. We contain maybe you want to input the bulk density, you understand, but before you can actually characterize assay, you must input one curve, maybe distillation curve or chromatography curve data, and maybe viscosity. Then maybe you want a curve of molecular weight or density curve or this waxing K factor curve, you understand, or you specify the bulk properties of this value. So those are the two things that is needed in order to fully characterize assay here. So but for my own, I'm going to be using the bulk property, not the curve. So that's why I said using bulk properties, and I'm going to be using chromatography curve instead of these are distillation curve, two boiling point curve, ASTM D1886 here. So these are distillation curve. That's special correlation. This one too is vapor pressure curve. So this is chromatography curve that determine the constituent of the assay when it is tested in chromatography analysis. So but this is data that I have. So light chain, like I said when I was starting this video, you can choose to ignore the light chain. That is, the light chain is part of the assay, but you can do special analysis for the light chain. So I'm going to input composition for the light end. I mean, so And there's something that is called handling and fitting here. So it helps you to know if you are putting a curve. Look at this bulk value. You start like distillation curve. I'm saying that it include light end. The molecular weight include light end. So you tick all this so that it should tell Aspen HYSYS that the bulk properties of molecular weight and the viscosity data that you put. The viscosity one and two are just they are not important, they are not mandatory. You can just put them in order to increase your accuracy of your simulation of the model, and you understand. So molecular weight, it will include the light end, that's meaning. So if you are inputting the curve but you are not inputting the curve, you can also say the curve include the light end, you understand, or it doesn't include the light end components, you understand. So then this one is the adjustment, like this, the regression and interpolation value for the curve, because sometimes you don't specify the code for all the components. Aspen start to extrapolate the curve in order to get the remaining components, you understand. So so we have the so I'm going to start with the bulk properties. So it's just simple thing to do. So once we have the bulk property, you specify for my data. The data I'm using is for this HYSYS manual here. So we have the components and the residue here, and this is the um chromatographic data for the components. Yes, so we are going to be putting this data there. So for the bulk properties, the molecular weight of the crude oil, the bulk property for molecular weight for the crude oil is 79.6, while the density is 0.6659, specific gravity API. So it's going to be converted to write density value. API density is different from just specific gravity density. So I don't have data. You just have to specify two of these. Maybe this curve and this. You don't need to specify the last one. That's why it's blacked it out for me. You understand? Make it calculated value. You understand when I calculate the assay. So this one I don't have it, so I'm just going to leave it at that. So what's the gives factor is just the approximate index of paraffinicity. That is the amount of paraffin. Paraffin is another name for methane. You understand, straight chain hydrocarbon. So the amount of how straight chain the crude oil is, something like that. So the next thing is I'm going to go to the license tab. So this is composition. You notice I've already given me the normal boiling point of the component of the lighting component like that. So I can just input the composition also. Okay, so I'll copy and paste the composition. So this is composition. So methane composition is in liquid volume. So it's supposed to be in more percent. So more percent, like 41.83 more percent, not liquid volume percent. Be mindful, the more percent different from liquid volume. Like the liquid volume percent is different from mole percent and mass percent here. So be mindful of that too when you are doing it. So we have the paraffinic composition too. So you have to specify the paraffinic composition. Make sure the basis in more percent, more fraction, something. So I'm going to paste the paraffinic. Just input all these values in your own simulation as you're doing it. I'm just copying that to make the video faster. You understand? So we have the aromatic value. We have the aromatic value. So copy the aromatic. So the next thing is, oops, let me check this aromatic. Okay, it's a mole. So this one is a mole. So this is the, okay, I'm going to copy this. So okay, this is the last naphthenic, which is the naphtha content. So once you have this, it's the next thing is okay, although let me just check some. This is explain this one. This is like if you are using boiling pot curve, because it's hard to convert all these D86. That one is it's a custom boiling pot. The default, the internal boiling point that Aspen Plus use to characterize the assays true boiling point curve. You understand? So you have to convert it to the true boiling point curve. That's many of us. So he's going to use a convention, interconvention method. You understand? So he's going to be using this API network. So you can choose all these. Maybe this is when you are working advanced, not really if you are doing the simulation. You understand? Then we have the correlation for raw laboratory data. Sometimes when they do the experiment, they didn't correct the value for true boiling point data with the laboratory barometer pressure. So you can do the analysis, do the correction by yourself. Our access Aspen plus Aspen HYSYS to do the correction for you. You understand? So you just use this section here by pressing yes and inputting the lab barometer pressure. You understand? So and also this is cracking conversion. In case that is for all these ASTM D86 API craft. In case you want Aspen HYSYS to use the cracking correction factor, you understand, the two boiling point that you or any or D ASTM D86 boiling point that inputs for the assay. You understand? This one is just like an extrapolation method that you want it to use to calculate the unknown component that you didn't input. You understand? Because I still have to extrapolate those values, so you can choose the method you want to use. Like I said, it's just for advanced. The default one is enough for you if you are doing basic work. You understand? So this is the result that you get after you have calculated the assay to cut the assay into different points. You understand? And give you the most and the cumulative and the normal point of the point that you cut the assay to, and the mole fraction, the mass density, the viscosity, and the velocity. Viscosity one. This one is at viscosity. Let me show you again. This okay. Let me check the point for it. The one is at the temperature that you input. This one is at 100 Fahrenheit. While the second is at 210 Fahrenheit. You understand? So then you can plot the data. You understand? This is like even the one that I've actually input. So I'm going to calculate the assay by just say calculate assay. Yeah? So as assay was calculated, you understand? So it's normalizing the values. You understand? So that's what the meaning of calculation of assay is all about. So you can see this value now. Everything has normalized, and this is cumulative moles. You understand? So you can plot the value here to if you see anything. If you want to add any user code, you can do it there. So the next thing you are done with assay is to do blend, like the Aspen Plus product simulation. So to do the blend, you click on this tab. So you add a new blend. You understand? Then you can pick available assay that you are, mix them together the way you want in the ratio that you want. But we have just one assay, so I'm just going to take this assay only. So I'm going to add it to my simulation. So although this one is using, like when you, the meaning of blend is to generate, basically in Aspen HYSYS is basically to generate Hypo Components. You understand? So to do that generation, you can use different kind of range, cut range. You understand? So I'm going to be starting. This one is auto cut. You understand? Auto cut is having a default cutting method, so you can specify the amount of cut. Like this one, auto cut is going to be like auto cut. Okay, auto cut the blend into components, hypo component based on these cuts or cut notation. You understand? Like within this temperature range of the assay, to is you understand 100 to 800 Fahrenheit is going to have 28 cuts. 800 to 1000 to Fahrenheit is going to have 8 cuts. That is 2 per 100 Fahrenheit. You understand? Then 1200 and 1000 to 1600 is going to have 1 cut per 100 Fahrenheit. That is 4 cuts. You understand? While you have user point cuts, which you have 4 per 100 within this initial boiling point. This one doesn't take care of the initial boiling point of the assay and the final boiling point. The final boiling point is the boiling point of the heaviest component. You understand? While the initial component boiling point is the boiling point of the lightest component in the assay composition. You understand? So this one take the initial and the final boiling point of the assay into consideration. You understand? So and it's cut it due to this using this method. You understand? Why the user we have the user with number of points. You can specify the number of points too. So I'm going to use user points. So yeah, number of cuts. I mean, so user point is the one that you specify by yourself. So I'm going to specify the number of cuts that I want. So it has done the calculation again for me. So right now, once everything is calculated, you have to just check the value. This is the cut or component name that is gotten from the assay. So you can access this component when you install the oil. So you can see the properties, number of point for the components, just like a braille component, for like propane, methane, you understand? So you're going to add this up to the crude oil and specify the composition, molecular weight, density, viscosity, and all this kind of thing. You can see the other properties like critical temperature, critical pressure, acentric factor, and the waxing K factor. So this for the blend. So you can do molar composition of the crude oil. You can see the molar composition of the blend is this H2O, the 0, H2O is 0. Like it's not really that 0, but little, you understand? So and we have the number about the hypo component that we have generated for the higher hydrocarbon in the crude oil mixture, you understand? So this is it. So we have the light ends too. This is our composition of reading. This one is from the light end composition that we input to the assay, you understand? So you can look for oil properties like true boiling point of the crude oil, you understand, of the blend. So a lot of this, you can see the distribution of the data, you can see. So you can even plot the distribution here, like the amount of naphtha in the crude oil. You understand the fraction of naphtha, the fraction of kerosene, the fraction of light diesel, the fraction of heavy diesel, and HGO, atmospheric gas oil, and the residue that you are expected to be seeing the fraction of the residue that you have in the crude oil. So this is straight on. You might change the cuts. You understand the cuts information by changing the type of crude oil that you have. If you have a straight run, you can see light cycle gas oil. You understand this is the fraction for it. So if it's a vacuum oil of gas, light vacuum gas oil, heavy vacuum gas oil. You understand? So I'm going to change back to straight on. So you set the distribution plot. Okay. Oops. So I'm going to okay, this one is when if I want to plot the two boiling points. So you can plot it and compare all these kind of boiling points for the for the for the blends. You see the data and we plot it. Yes, and so you can plot it with more and see different plot and save the plot if you want. So that's that. Okay, so this is the distribution plot. This is for each color corresponds to each component. So you can get the legends by clicking on graph control. You see all this plot color for naphtha and all this kind of thing. So that's that. You have the composition, composite plot, and the rest. So you have correlation for the data too. So that's on blend. The next thing is just to install the oil after you have the blend. So you have the blend now. So the installation of oil is just to put the oil or the crude oil in the flow sheet simulation in the simulation environment. So I'm going to add a stream for this flow sheet for this oil. It's all that I have for this blend that I have. So I'm going to call it gas well. Oops, gas well 11. I think I'll have the name 11. So you can signify the page that you want to the flow sheet. You have sort of flow sheet in Aspen HYSYS. So this will be in the main flow sheet of the simulation. So you see the stream once I go to the main flow sheet now. So I'm in the main flow sheet. You can see the stream. So this is our stream that we want to do simulation on. So I'm going to, you can see the composition will be filled this is the composition. So you only have to specify the thermodynamic or condition of the stream. So I'm going to just this is a typical condition. So this one is 35 degrees Celsius and pressure of 12 bar. So the flow will be 545 kilogram per hour. So let's see. So this is on hold, so I have to just make sub active before it calculates it. So it has calculated the stream. So this is the vapor that you're going to see. This is the liquid. It's going to be the vapor fraction, you understand? And everything is now working fine. You see all the many properties of the stream, just like a typical stream in Aspen HYSYS, you understand? So you can now continue to do your refining or your simulation of the crude oil that you have just characterizing. I made a mistake with the names. Supposed to be gas well 11 in Aspen HYSYS. So that's be the end of this video. So we'll be doing more videos on this topic here. So stay tuned to our channel. So thank you for watching.